All right, today, oh, it's February. Oh, spring's going to come, isn't it? Sure hope so. 2/1/23. So our objective today is we're going to look at different, so the different forms of a linear function. Okay, and linear always means straight. Linear always means a straight line, okay? So when you see the word linear, it means a straight line, not a curve. Those are like parabolas and polynomials and all sorts of weird things, but linear means straight lines, okay? So basically, we're going to look at four different types, okay? General form is sum ax plus by equals c, and of course it's always nice to have an example. An example would be, I don't know, let's see, 3x maybe minus 4y equals 12. And then the advantage to general form is graphing by intercepts. Remember the cover-up method? Right? Cover-up method, and then you can graph pretty easily if it's in general form. Plus, a lot of story problems are done in general form, okay? Or standard form. Slope-intercept form, you guys know this one. This is our favorite. This is our favorite. It's our y equals mx plus b. And that's the easiest for graphing, okay? So an example, you know, I don't know, how about y equals 2/3 x minus 4. Okay, that's slope-intercept form. Emily, so we'd start at -4, right? Put a dot and we'd go up 2/3, up 2/3, right? Point slope formula, which is one of my favorites. Not everybody likes it until you get used to it. Then you'll like it a lot. And that's the y minus y1 equals our m times our x minus x1. The advantage of the point slope formula is making the equation. So an example of this would be if you have a point, let's say point A is, I don't know, 3, 5, and you have a slope, okay? And the slope is, say, I don't know, let's make it 2, right? So the advantage to the point slope formula is if you have a point and a slope, you can plug them in and come up with the advantage with the equation, okay? Now the intercept form is never used, but it is this: x over a plus y over b equals 1. Has to equal 1 to be intercept form, okay? I'll show you an example. If you had an x over 3 plus a y over 5 equals 1, then you know from this example, am I going too fast?
Yeah.
I'll wait for you, okay? Slow me down if I do, okay? You won't see this very often, but it is another form. And I'll wait for you and I'll show you an example, okay? Lexi, give me thumbs up when you're caught up, okay?
Okay.
Emily, you good?
Yeah.
So, an example. In this example, I know that the x-intercept is at 3, 0, and the y-intercept is at 5, 0, 5, okay? These numbers, that's the x-intercept, that's the y-intercept, and you can graph the line. Dot, dot, connect the dots, okay? Has to equal 1, though. It's rarely used, but it's one of the forms, okay? So let's use these. Let's go ahead and take a look at the first example, okay? Example 1. Given, find the equation line passing through 1, 4 and 5, -2, okay? Use the point slope formula, okay? But before we can use the point slope formula, we got to find the slope, okay? And we're not going to do it by graphing. Graphing can work, but you can't graph everything. So I'm going to find the slope first. So if I'm going to do this problem first, let's find the slope, okay? And I know that the slope formula is the y2 minus y1 over x2 minus x1, right? So first thing I'm going to do is find the slope. So every point has an x and a y, x1, y1, x2, y2. That's not squared, it's just the second x value and the second y value, okay? So then, the slope here would be, I'm going to have a 4, or actually a negative 2 minus 4 over a 5, a 5 minus 1. Did I make a mistake? Negative 2 minus 4. No, I think I get it right.
Yeah.
And then that would be a negative 6 over 4, right? Which is negative 1.5 or negative 3/2. Either way, whatever you like. Do you like a fraction? Do you like a decimal? It doesn't matter. Okay, so now the second thing I need to do is I need the equation, right? I mean, it actually asks for the equation. So on the second piece, since I need the equation now, is I'm going to use my point slope form, which is that one right there, all right, point slope form, that one right there. So I'm going to write that down. I'm going to use my second thing I'm going to do is I'm going to use my y minus y1 equals my m times x minus x1. So I want to use that formula. Y is my variable, x is my variable, y1 comes from the point, which is 4, x1 comes from the point, which is 1. So I'm going to go, all right, y minus 4 equals negative 1.5 times my x minus 1. Okay? And then I'm almost done with this problem. Just have to finish it up. I'll distribute, right? And I'll have y minus 4 equals a negative 1.5x plus 1.5 plus 4. I'll have a y equals a negative 1.5x plus a 5.5. Okay, so what is this? This is the equation of a line that will pass through both of these points. This is the equation of a line that will pass through both of these 2 points. Okay? Thumbs up? Okay. Turn the page. All right, here we go. So, examples 2. Okay, find the equation of a line parallel to 2x plus 3y equals 6 passing through negative 6, negative 12. Okay, so what I need is the equation of a line, right? But it's got to be parallel. So there are a couple of things. First of all, parallel, I need a slope. So I am going to use this equation, my y minus y1 equals m times x minus x1. I want to use that formula, but I need to find the slope first. So let's find the slope. So to find the slope, I'm going to solve for y, okay? So I'm going to, minus 2x, right? And I'll have a 3y equals a negative 2x plus 6. I mean, all I'm trying to do is get the slope. So I'm just going to solve for y to get the slope. Divide by 3 to get y by itself. And I have a y equals a negative 2/3 x plus 2. Okay, awesome. I just wanted this, right? That's all I needed. Now, these two lines are parallel because they'll have the same slope. So now I'm going to use my equation, right? Find the equation. So I'm going to use my y minus y1 equals my m times my x minus x1. I have a point that it's going to go through. That's my x1, my y1. And I have a slope. So I'm just going to plug it in. X and y stay as x and y because those are variables. So I'm going to go y minus y1, which is a negative 12, equals my slope, which is a negative 2/3, times my x minus my x1, which is my negative 6. Okay? And I'll slow down for a second. Okay? So all I did was to put my slope into my formula for m, my point, negative 6, negative 12, into the formula for x1, y1. Okay? All right, to simplify, double negative, make it a plus, double negative, make it a plus, right? So I have a y plus 12 equals, and I'm going to distribute. I'm going to get a negative 2/3 x minus, okay, you ready? 3 goes into 6 2 times 2 is 4, okay? That's how I did it. 3 goes into 6 2 times 2 is 4. And then I'm going to go ahead and finish this. I'm going to go minus 12, minus 12. Okay, Reese, now I'm going to make an observation, Reese. This is for you, okay? So, because of the negative 16, this might not have been too easy to graph, right? But you could. You can do this problem by graphing. Does that make sense? You can. You can graph the point, know the slope, and just draw it until you find your y-intercept, okay? But it's way down at negative 16. All right, number 3. Let's do the perpendicular bisector, but this time using the math, because you can't always graph these, okay? So, we know a couple of things. To be perpendicular, we need to find the opposite slope, right? That's what Retta said. I agree, Retta. And the bisector, I think Julian said that was the midpoint, right? So we have to find both. We have to find both. So first, let's find the slope, okay? First, let's find our slope. So m equals y2 minus y1 over x2 minus x1. So negative 5 subtract 3 over 4 subtract a negative 2. Okay, so I got to find the slope. So my slope is going to be negative 8 over 6, which reduces to a negative 4 over 3. Okay, I got the slope, but, Retta, what do I have to do? Yeah, so what I really need to do is the perpendicular slope. So how about 3 over 4, right? Because that's the slope I want. Now I need the midpoint, okay? Now, the midpoint, we have a formula for the midpoint. The midpoint is our, and I'll write it down again, x2 plus x1 over 2, comma, y2 plus y1 over 2. That's our midpoint. So I'm going to take, for my midpoint, I'm going to have a 4 plus a negative 2 over 2 and a negative 5 plus a 3 over 2. Okay, that's just my midpoint formula. And yeah, you can graph this, but I want to do it algebraically because you won't be able to graph them all the time. I get a 2 over 2, so I get a 1. I get a negative 2 over 2, so I get a negative 1. Okay, so that's my midpoint, okay? All right, so 2 important pieces I need. Okay, I've got my slope, and I've got my midpoint. Okay, now, last thing is I need the equation, right? I need the equation of the line. So I'm going to use my point slope formula, which I like. So I'm going to go to my y minus my y1 equals m times x minus x1, right? I have to use my midpoint. Have to use your midpoint because it passes through our line that we're trying to make. Have to use the midpoint. Can't use the other points. Have to use the midpoint. So I'm going to go y minus a minus 1 equals 3/4 times x minus 1. Okay? Double negative makes it a plus, and I'm going to distribute here. So I have a y plus 1 equals a 3/4 x minus 3/4. So I'll go minus 1, y equals a 3/4 x minus 1 and 3/4. Okay, this is the line that goes through the middle at 90 degrees. This is the line that goes through the middle, the midpoint, at 90 degrees or perpendicular. Okay,